Hello everyone, Assalamu alaikum. Hope you guys are doing well. In today's session, we'll be covering 0580 paper for grade 3 of the May June series 2023. So let's start. Some basic instructions that do need to know that the tracing paper, we are allowed to use the tracing paper. And for non-exact answers, we are supposed to write the answers to three significant figures or one decimal place for the angles. And for diagrams, it's preferable that we use pencils. Okay, so let's start with question number one. Thomas sells a computer, a bike, and a phone. He's selling three items. The amounts he receives are in the ratio these. Okay, so the ratios given are in the same order as to suppose the items. So computer has the ratio 14, bike has the ratio 17, and so on and so forth. Now we are supposed to calculate the amount he receives for the phone as a percentage of the total. So you're supposed to see that one of the items is phone, and phone is having a ratio of 17. Is that correct? Or it's actually 9, because for bike it's 70. For phone it's actually 9. So it's going to be 9 over what? Now 9 over the total, because you're proportionating it to the total. So it's the ratio of phone to the total that he receives would have to be based upon when we add up all the three. So what will we get? Add up 14 plus 17 plus 9, we're getting 40. So it's supposed to be 9 over 40. And now, since we are not, we are supposed to give it as a percentage of the total. So the answer should be in percentage. What's the total percentage that we normally use? Like, what's the total percentage? That's 100. That's why we are going to multiply it with 100. And it's going to be 9 into 40. 9 upon 40 into 100. That's going to give us exactly 22.5%. That's your answer for question one, part A, part 1. Because percentage is mentioned, that's why we are using 100. And we just found out the ratio of amount that he receives for selling the food. The total amount now is given in dollars, not in percentage, that he receives is 560. Calculate how much he receives for the bike. Now for the bike, the ratio was 70 and the total was 40. Again, we are going to proportionate it to the total because he has received the total amount to be 560. So times it 560. So 17 times 560 divided by 40, that's going to give us $238. Thomas originally bought the bike for $195. So the bike was originally for $195. And he wanted to make a profit of at least 25%. The profit of at least when he sold it. So the cost of buying the bike was 195 and he wants at least 25% profit. So I'll add the 25% to this, or we can just do directly 125% of this. So we know the selling price as to at what price you should have set. But let's not do that. Let's not get ahead of ourselves. Let's read the question first. So does Thomas make a profit of at least 25%? So we have to check if he has made a profit of that or not, depends on what price he sold it at. So he sold it at 238. Yeah, because that is uh, what was asked in part 2. Calculate the amount he receives for the bike. So he has actually received 238. That means he has sold it for selling price that you have 238. He sold it for 238. Now we need to check if he has made the 25% profit or not. And we're supposed to show all the working. So do not skip any working here. So we'll see the difference here between 238 and 195 first. It's the percentage change formula, which is new minus old upon old. That's what we are going to do. So that's old is 195. So we have, and we times it by 100. So we know the percentage change as to how much profit he has actually made. 238 minus 195 divided by 195 and you times it by 100. So you're getting something around 22.05 or 22.1 to round to basic known figures, which is 22.1 is less than 25%. So we are making a profit of uh, less than 25%. So the answer should be no, as 22.1% is less than 25%. So he did not make a profit of 25% because for him to make a profit of 25%, we'll just do 195 times 25% would mean you add up the to 100 plus 25, so that's 125%. So 195 times 125%, that's going to give me the selling price. He should have sold at minimum to make a 25% profit. So that should have been his selling price in order to make a 25% profit, but he actually sold at 238. So the answer should be no, he did not make a profit. This is just for explanation purpose, is not actually required in the answer working. Pula invest $725 for 6 years in an account paying simple interest. So that's the first thing that we need to account for is that we have simple interest on the question. At a rate of 1.3%, that's the rate. Calculate the total interest earned at the end of 6 years. So this is straightforward for total interest earned. Total interest earned. The formula would be P times R times T over 100. P is the principal rate that we have, the amount at which we start with, $725 times the rate, which is 1.3 without the percentage, because the percent 100 would actually be accommodated here when we divide it by 100. And then multiply it with 6, the time in years. Then we can use the calculator to solve this. So 725 times 1.3 times 6, whole thing divided by 100. That's going to give us 56.55. And do not round this up because this is an exact answer. So that should be the final answer. That's $56.55 the total interest earned. So for simple interest, that you need to know is that you use this basic formula and the amount of interest remains the same every year, and it's actually applied on the principal amount. So another way we could have just done this manually without using the formula was we could have just taken 1.3% of 725. It's the same thing, but just another perspective of looking at it. That would have given us 9.425. And since that's the interest for year one, and I need for 6 years in total, so I'll just times it by 6. So I'm getting the same answer as 56.55. So that's your OR method, which is the same, pretty much the same thing that we did. Okay, next part, in a sale, all prices are reduced by 24%. You're reducing the prices by 24%. So in actual, if you're reducing by 24, so you are actually at 76% because it's discounting. Victor pays 36.86 for a pair of shoes in the sale. So this is the after discounted price. So 76% is actually in terms of dollar price 36.86. And you're supposed to calculate the original price. So original would obviously be 100% because that's the assumption we take when we're actually adding or subtracting from 100. So we always assume the original to be 100%. We'll just cross multiply them. It's going to be 76. You can do it with the percentage sign or without the percentage sign. That's the same thing, does not matter. So I'll just remove the percentage here because they'll eventually cancel out. So it's just 76x adds 36.86 times 100. Then you take the 76 and divide it on the other side. Divide by 100. Divide by 76 actually. And then we can just use a calculator. 36.86 times 100 divided by 76. So that's going to give us 48.5. And that's the original price. You can even cross check by for reducing 48.5 by 24%, you should get 36.86. That is how you can cross check your answer. Let's move on to the next question. So Anna records the number of text messages she receives for 14 days. So you have 14 data values. This tells you the total. You have a total of 14 data values. You're supposed to complete the stem and leaf diagram. Okay. Now there are certain things that you need to be aware of when you're making a stem and leaf diagram. Is the numbers here. This is actually the stem, by the way, and this is the leaf. So I'm talking about the numbers in leaf should actually be in ascending order. Smallest to largest, smallest to largest. So you cannot write them in any order. You have to arrange them in smallest to largest order. That's one thing you need to be aware of. Second thing is that if I'm writing a number here and then here, let's say this is random number just to explain. So the other number should also be here below this. It cannot be midway around, like it should follow the same pattern, and we can work around without using commas just by leaving spaces. That's good enough. And obviously, the last thing is we do have to write a key for this. The key is very important. Do not miss out on it. Okay, so let's just do this real quick. So for one, now the best way to do this, guys, there are multiple ways you can do this, but the best way to avoid error and to not miss out on any value is you take the line of 1 and then we write down all the numbers that we can find from out, starting from, so we're going to go travel in this manner. Actually, this would be better, yeah. We go from first line, that's 1, and then that's line 2. So we do not miss out on it. So I can see 17 straightforward. The first uh, number that I can straightforward see is 17. And then I can see 15, 13, 18, and then I do not have any other number. Now I just need to arrange them in the correct order. So let's just do that. Let's just find out for the other line as well, and then we'll do it all together. For the second line, where the stem is 2, so we'll have 21. Let's follow the order actually. Do not miss out on the order. Go in this particular order so you do not miss out on it. That's the second value, the third value, the fourth value, the fifth value, the sixth value. And lastly, yeah, this value is there. Lastly, for the line of stem of 3, we'll have these 3 values. And now I'll you could have just written this here instead of using a highlighter. Obviously, you won't have a highlighter, so you can just write down the numbers here and then can arrange them. Like for example, if I do this for the line of 1, for the stem of 1, so it would be 1, 7, 1, 5, 1, 13, 13, and 18. Now I can arrange them up, so I know the first number is going to be. Now make sure that you remember that the first digit is actually being taken as a stem here. So the second digit is only left. So we'll write that in the key as well. So let's just complete this. So this is going to be 3, then you have 5, then you have 7, and this is going to be 8. That's how it's supposed to work. For the second line, it's going to be 1, 1 again. Go in the correct order. Make sure you do not mess up the order. That's going to be 22. And then what value do we have? 27, 28, and 29. That's 6 values. Do we have 6 values? Yeah, we have 6 values, but I think we have shaded wrongly here. This is incorrectly, not this one, this one. Yeah, this has been wrongly shaded. Let's correct that. Yeah, that's in the stem of 3. Now it's perfectly fine. And let's just fill in the last stem. So this is going to be 1, 1, 1. And then we're going to have, so that's 4 values in total. That's 6 values, and that's 4. Does that make 14? Yes, that does make 14. So that's absolutely perfect. Yeah, so one thing still you won't get the full marks if you do not write the key. So the key is gonna be, this is how we're supposed to write the key. So let me zoom in on that. So that's 2. I make it that line in between. So I'm saying 2 is just 10 and the leaf is 7. So this means, what was the data representing? Read that again. Number of text messages. So it's gonna be means 27 messages. That's going to be 2 dash 7 means 27. So basically, it's a very straightforward strategy. You're taking the first digit as 10 and the second digit as 8. That's your final answer for this question. Find the median. Okay, so for the formula for median that we use is n plus 1 over 2 term. So using that, n is the total number of values that we figured out in the data set of 14. So that's 14 plus 1. That's going to give us 7.5. Now the issue with the decimal number is that whenever we have a decimal number, we take the closest two integers, which is 7 and 8. So now we are actually in search of the 7th term and the 8th term. Let's find them up. What's the 7th term and what's the 8th term? So again, the purpose of writing them in ascending order was also to help with such kind of questions where your order is in this particular order you're going. So that's 4 terms, and that second row means end of second row means you have a total of 10 terms, and then end of third row means you have a total of 14 terms. So that's your first term. Second, third, fourth, fifth, sixth, seventh. That's my 7th term. So that's just going to be how much? That's going to be 22. Please do not write 2 and write the complete number, which is 22. And the 8th term is obviously going to be the number next to it. So that's this one. So that's going to be 27. Now what are we supposed to do? We have to take the average of both, because whenever you have a decimal number, you take the closest two integers and you take the average. How do you take average of something? Of two items is you add them up and you divide them by 2. So that's just going to be 49 divided by 2. That's 24.5. That should be a final answer for this question. That's your median, 24.5. The mode is what? Most occurring value, or value with highest frequency. Highest frequency value. So we'll just look at the raw data that we have to find the mode, the value that is repeating the mode, or you can use this term as well. So we can see 3 ones in the row, third row. That means 31 is coming thrice. Is there any value that's coming thrice other than 31? Like this is the values that I'm talking about here. So 31 is coming thrice, so that's just going to be a mode. Most occurring value is going to be 30. Range. Now this is actually simple range. Simple range. This is not interquartile range, this is simple range. The formula is straightforward: max value minus minimum value of your data. So what do we have as the max and minimum value of the data? This is very easy to see. Max and minimum value of your data are just the numbers, the last number of your stem and leaf and the first number of your stem and leaf would be the max and minimum value if you have made the correct stem and leaf. Otherwise, you can use the question data or data. So that's 13 as the minimum value and 38 as the maximum value. When I subtract them up, I'm getting 25 as my range. In a shop, there are 4 red and 8 gray phones. So you have red as 4, gray as 8. Anna and Pete each pick one of these phones at random. So they're both picking one of the phones. Work out the probability that they both pick a gray phone. Now we need the probability that both Anna choosing gray and Pete also choosing gray. We need the probability for that. So let's say Anna goes first and she picks up a gray phone. So what should be the probability for that? So we just use basic probability formula of any event is that favorable outcomes over total outcomes. So what's the favorable number of phones that we have? Gray as 8 and the total number of phones by the way are 12. That's just going to be 8 over 12 times because there's an and in between. There's Anna and then Pete. So that's why we'll times it because in probability and is means to use a multiplier and or means to actually add up. So what's the probability of Pete choosing a gray would be again this time it's actually it's going to be 7 upon 11 and not 8 over 12 because the amount of gray phones would have reduced in the shop after Anna has picked one of the phones. So the quantity would have actually reduced for the gray phones. And obviously the total phones in the shop would have decreased as well because after Anna choosing, it would have been 11 phones left in total, which out of which 7 are grey and 4 are red. Because Anna actually chose a grey phone, so the probability of for the quantity of grey phones actually decreased. So that's why this is going to give you, when you multiply this up, yeah, so 8 into 7 upon whole thing divided by 12 into 11, that's 14 over 33. The probability of both of them picking a grey phone. Okay, so let's read question 3. The scale drawing shows two sides AB and BC of a field. The scale is 5 centimeter representing 200 meters. So keep a check for this that 5 centimeter are being represented in 200 meters. For the first part, we are supposed to measure the angle ABC. For this, we'll need the protector ABC. So the angle that we are actually calculating is the angle B. So we'll keep the point of protector at this particular point at the start, and we need the angle. We need this particular angle. This is the angle B. So since we're starting from we're going in the anti-clockwise direction, we are starting from right to left, and this is the point where you have 0. So we'll look at the outer side of the protector, the numbers that are outside on the border of the D. So like this. So we'll stop at this particular point, and which is approximately around here. So let's check for that closely. That's around 118. Yeah, that's around 118. To be exact, you might should make sure you do this properly so you can figure out the exact answer here. So it's coming around to be somewhere around 118, 119. So we'll write 118 as the angle. Because you're supposed to measure the angle, so you do not have margin of error here. The marking scheme also says the answer to be 118. So let's just write that down. That's 118 degree. That's your answer for this part. We've measured the angle B. Now let's read the next part. X is a point on BC. So X, this is the line BC. Let's remove the protector. Yeah, so we have this line BC and X is somewhere on that line. The length of BX is given 332 meters. So key thing to note here is that it's actually in meters. So since we realize that 5 centimeter is being represented as 200 meter, how much would be 332 meters in terms of centimeters? For that, can we just cross multiply and solve? So when we do cross multiply, we're gonna get 332 times 5 divided by 200. So that's gonna give us x to be 8.3 centimeter. So 332 meters, according to that scale that we have here, is gonna be in centimeters 8.3. So basically gonna need a ruler to, because we are supposed to mark the point x on the diagram. So x can be anywhere, like possible positions of x on the line. We're supposed to mark the correct position, and that only we can do using the length of dx. So the distance from point B should be 8.3 centimeters. So I'm going to place the ruler. So on B, the 0 point should be on B exactly, accurately. Once I have that sorted, I can zoom in here and mark 8.3 as the point where x should be. So that's 8, 8.1, 8.2, 8.3. Yeah, that's your point for x. Now we can remove the ruler. And we'll make a note here that this is point x. Since bx is 8.3 centimeters, which is the equivalent of 332 meters according to the scale that they have given us. So that is how you were supposed to do the first two parts of this question. Okay, so the third part says find the scale in the form of 1:n. Now, if we look at the initial scale that we have is 5 centimeters ratio 200 meters. That's the scale that we have currently as of now. Now, we have to make sure that the number on the left is 1. How can we make 5 1 is when we actually divide it by 5. And since we do that on this side of the ratio, we have to do that on that side of the ratio as well. So this is just going to become 1 centimeter. And 200 divided by 5 is going to give us 40 meters. Now the final issue remains is that you do not have the unit same. When the examiner says express or find the scale in this form 1:n, do you notice any units here? You do not. You don't have any units. That means the units should be same. Of both the quantities, you should have the same unit. So if you're using, since this, the left number had to be 1 and you had made it 1 centimeter, so now you have to write 40 meters in terms of centimeters. How do you convert 40 meters in terms of centimeters? For that, we'll just do the working here. So since we already know that 1 meter has 100 centimeters, this is not on the scale. This is generally how the measurement works. 1 meter is 100 centimeters. So how much would be 40 meter? That's x, and then you can always cross multiply them. So that's x times 1 is just x, and 40 times 100 is just 4,000. So it's going to be 4,000 centimeters. So next step, it's going to be 1 centimeter ratio 4,000 centimeter. That, and the value of n is actually 4,000. So it's 1 ratio 4,000. Now this, since they are in the same, that's how you're supposed to do this. Okay, next part is part B. A bronze statue is 4.5 meter high and has a mass of this. The density of the bronze is this. Okay, now since you have the volume of a mathematically similar model of the statue, you have another statue. So the best way to do this is to first understand the information in a nice and easy way. Let's just call it statue 1 and let's call this statue 2. And what do we know so far? So for statue 1, we know that high would mean height. So that height is 4.5 meter, mass is 195, 200 kg, and density we know is actually 8,000 kilograms per meter cube. Yeah. Do we know the volume? No, we do not know the volume of statue 1. However, for statue 2, the volume of a mathematically similar. Now, what's similar? Exactly same, however, can just differ in size. Can be bigger or larger. We do not know that. It's a similar model of the statue, and height, mass, density. None of that is given. The volume is actually given as 0.385 meter cube. For statue 2, you do know the volume, but for statue 1, you do not. Now let's read the final requirement of the question is you're supposed to calculate the height of the model. Now the model actually is which statue? Model is actually statue number 2. Also, we can write it here. So what we are actually looking for in this question is this height. This is the one that we are actually looking for, the height of statue 2. That is what we are supposed to find out. But before we find that out, it's a question of similar objects. So we'll need to find the volume of statue 1 first. So we can apply that formula of similar objects. What's that formula for similar objects? So the formula that we do know, formula for similarity in case of volume. We do know that volume of one of the object upon volume of the other object is L1 over L2 and cube. You cube it to make the unit same actually. You can the proportion of lengths remains the same, that's the logic, and you're cubing because you're making the unit same, because here the unit would be actually meter cube, and for any length that may be height, the unit is meter. So in order to make the same unit, we're actually cubing it. That's how the formula is derived. But we can work around without that knowledge as well. This is the formula that we are going to use for similarity. Now, let's just, we need the volume. We need both the volume so we can figure out the height. Height in this case would be the length that you're using. So that is why we need to find this volume. So in order to find this volume, we have a basic formula given as density is actually mass over volume. We do have density and mass. Can we not figure out volume? We can, because we'll isolate volume, bring it on this side and take the density on the other side. So in other words, it's actually volume is equals to mass over density, which means that it's going to be 195,200 upon 8,000. And obviously the kg and kg will cancel out, we'll get meter cube. When we do that on the calculator, so that's 195,200 divided by 8,000. We'll be getting 24.4. That's meter cube, your volume. So we have figured this out to be 24. Now we have the volume. So since we are using statue 1 as with the number 1, so we'll keep volume as 1. So that's 24 point, volume 1 in place of the statue 1 volume, 24.4. Volume 2 is going to be 0.3, 0.385. And then we'll write down the lengths, which in this case would be the height. So the height of the first statue is actually 4.5. And the height of the second statue is the one that we're actually trying to figure out. So we'll just keep it as H2, H1. So let's just keep that as H2, cube. And then we can apply cube root on both sides to cancel out the cube. So we'll have cube root of 24.4 divided by 0.385 equals to, and this is Square a cube and cube root would cancel out. So you're just left with 4.5 over h2. Now we need to make h2 the subject, so we need to isolate it. We'll bring it on this side since it's already in the denominator. We need to bring it in the numerator. We'll multiply it here. So it's going to be h2 equals to, and this whole thing would actually get divided. So it's going to be 4.5 divided by cube root of 24.4, 0.385. And now when you plug that in the calculator, so how you're supposed to do that is we write 4.5 using a fraction, and in the denominator you use cube root, then you use a fraction again and you write 24.4 divided by 0.385. Make sure to not make any silly mistakes while putting it in the calculator. And then one go, you'll get the answer to be 1.1286 or 87, but we'll round it to three significant figures, so that's 1.13 meter cube. Oh, sorry, it's going to be meter only because it's the height. So that we managed to figure out. That's the height of the statue too. Okay, so let's move on to the next question. Okay, so we have bearings here. Some things to keep in mind for bearings is that you're starting from the north always, where the bearing is actually, that's point number one, bearing is actually in 3 digits. And you're going in anti, or actually it should be clockwise direction. We're going in the clockwise direction. And since you're starting from the north, so your initial bearing is 0, 0, 0. That's the starting point. And you're going in the clockwise direction like this. And you write the bearings to 3 digits always. Now, ABC are 3 towns that we have, and the bearing of C from A, from means the point from where the bearing should start, the north, is 114 that we can see as 114. And then B is due south of A. When something like this is written, due south of A, this means that it's literally below that, it's a complete straight line. So which line? AB line is complete straight line. So for using that logic, I can figure out this angle. This angle is just going to be 180 because on a straight line, the sum of angles is 180. So I'm just going to do this and I'll get 66. And then AC is equals to BC. Yeah. Since they are equal, it's an isosceles triangle ABC. So we'll have the base angles same. This should also be 66 degree. So we figured out the two angles obviously already. And in a triangle, when you do know the two angles, you can figure out the third angle always. So that's just 180, the total sum of angles in a triangle, minus the other two angles. When you add them up and then you subtract, so that's 180 times 180 minus 66 plus 66. So that's 48 is the third angle of this triangle. And now let's read what the examiner is asking. Calculate the bearing of B from C. So from C would mean that we are actually at the point. We are actually at the point C. That's the point that we'll be using. Yeah, so we're supposed to find the bearing B from C. So we'll be making the knot at actually C, because from that's where we are actually supposed to calculate the bearing. And the angle that we are actually looking for here is this complete angle from C to B. That is the angle that we are looking for. So it's obviously going to be more than 180 because it's crossing the straight line, and less than 270, somewhere around 180 and 270. And the entire circle, if I had the entire circle, it would have been 360, but can I say that if I somehow to calculate this, I do 360 minus 48, and let's say this angle is y minus y. So if I subtract this 48 and this y from 360, shouldn't I get the correct bearing or the correct angle, the required angle? So now all we need to do is calculate this y. How do we calculate this y now? So for this, we'll need to have a look at the angles. So this should actually be 66. And the reason for that is we actually have alternate angles here between parallel lines. The north and north are always parallel. So you can see alternate angles. That's why this is going to be 66 as well. And now we can just write down the bearing to be 360 minus the other two angles, which is 48 plus 66. And you get your required bearing. So it's going to be 246 digits. 246. Another way how we could have figured this 66 out was, if you see, these are two knots. So in reality, it's basically like this. So angles between two parallel lines are actually angles between the two parallel lines are actually adding up to 180. So that's 114 plus 66 adding up to, or interior angles between parallel lines are supplementary, adding up to 180. That's another way you could have seen that. Let's move on to the next question. So we have circle theorems here in part B. Okay. So PQRS lie on a circle. So the first thing I'm getting from this line is when PQRS, I look at PQRS and they're all lying on the circumference, the boundary of the circle. This means we have a cyclic quadrilateral this. We have a cyclic quadrilateral with the PQRS in which the opposite angles add up to 180. So using that knowledge, without even reading further, can we figure this angle out? Because since this is 74, so this angle is just going to be 180 minus 74, which is 106. Just using the knowledge of cyclic quadrilateral, I figured that out. MPN is a tangent to the circle at P. So MPN, let's look at MPN. Yeah. So we have this as MPN, that's your tangent to the circle at P. And do we have a radius that makes some tangent and radius make 90 degrees, but we do not. So the other property would be applicable actually here. The alternate segment property, that's also the tangent chord property, would be applicable here. Because we have a chord, we have lots of chords actually, because we have two triangles here. We have lots of chords. Chords are any line that touches the circumference points. So any 2 points joining together, any 2 points on the circumference joining together to form a line is actually a chord. Like, for example, we have PQ as a chord, we have RQ as a chord, we have SR as a chord, and we have SP as a chord. So those are chords, and we have the MPN as tangent. Let's read further before think what we can figure out. We can figure out more angles, but let's just real quick see what's the requirement of first part. Like there are two ways you can approach circle theorem questions. You could have tried to find as many angles as you can possibly and then look at the requirements, which is usually more preferable way. If considering it's a long question, that's the best technique to go with. Or the other method is you try to find it one at a time. I can find out more angles as per requirement, but let's just read what the first part is asking. Find the angle PRS. So it's going to be this angle that we are looking for, and we'll definitely need to use the property for this. So either way, we're going to find this angle. So let's just understand now how are we supposed to find this angle. So now what I just explained to you was the alternate segment property. If you're not aware of this, do read upon this. It's an important property, alternate segment. You usually have this when you have a chord and you have a tangent. They're making a, now you see the chord and the tangent. So we are looking at this chord and the tangent is this. The angle between the chord and the tangent, which is this 27, is going to be the same angle as the angle which is opposite to the chord in the triangle. So you usually have this in a triangle and you'll have a chord and tangent making an angle. That angle is the same as this angle that is opposite. That's opposite to your, that's chord. So your chord was PQ. So if I write that down, the chord was PQ. And angle between chord and tangent is 27. Angle opposite chord is also 27. Those are the two angles that you have same. So that means this is going to be straightforward 27 using the property that we just learned. The angle opposite to that. Okay, so I think that was the requirement of first part, PRS. So that's just write that down. That's going to be 27 using the alternate segment. Angle PQR. Okay, so PQR, I think we have already figured it out to be 106 using the cyclic quadrilateral. So let's just show the working here. 180 minus 74, that's 106. Okay, I think, yeah, we have made a slight mistake. I think this is not going to be 27 because he's asking for PRS actually, not PRQ. Yeah, so very important to read this clearly. It's PRS, not the angle that we found. We found PRQ actually. So the angle that he's actually looking for is this one, the other one. He's looking for this angle, and again, it's going to be the same property. So let's just do this again. Let's see how this works out. So we have the chord as SP. We have this as the tangent, the chord and tangent making the angle of 58. And since the same angle opposite to the chord would also be the same angle 58. So this in fact is going to be 58 degree alternate segment because of alternate segment. So this is going to be 58 degree. And so one marker, so you're just good to go with the answer itself. You do not need to write the reason here. The same property we just applied, the alternate segment or the chord tangent property. You can call it that as well. The last part requires us to find our PQ. Obviously, there are more angles that I can figure out. Yeah, similarly, like this angle is just a third angle in a triangle. Our PQ, is this the angle? Yeah, this is the angle that we're asking for. So we have two angles, 106 and 27. So the third angle is just going to be 180 minus. We'll add the other two angles and subtract from 180. So that square is gonna be 47 degree. Okay, so part C, let's read. So ABC lie on a circle. So we have 3 points lying on a circle. This won't make for a cyclic quadrilateral. Because for a cyclic quadrilateral, we need 4 points. We have 3 points here. The center is O, so we have a center O and we have diameter as AC. So that confirms it because diameter always passes through the center of the circle. That's a property that diameter has. And the end points of a diameter, the midpoint of them would actually be the center of the circle. Yeah, so the logic is pretty much sorted here. And we can figure out that we have radius in this question. And all radius on a circle are the same. So using the radius method, we do know that OC, OA, and OB are actually all going to be the same. So that's OA equals to OC equals to OB. They're all same because they are all radius. And what's the definition of radius? Any point from center of the circle to the circumference. That's your radius. And then you can, okay. And now we can also see that since these two sides are same, this and this, the triangle OCB is actually an isosceles. OCB triangle is actually isosceles. So this angle and this angle would actually be the same as well because it's an isosceles triangle. Having two sides same and two angles, base angles being same. Okay, so let's read further. This is all we have figured out so far from the knowledge that you gained. We have TM and TBN are tangents to the circle. So we actually have a pair of tangents, not just one, two tangents. This and this one. Yeah. So we have two tangents in the question, and this will lead us to the tangent kite property that we have learned in circle theorems, which implies two things that we do need to be aware of. And let's study for that two things. And then he has given us the angle to be 34 degrees. We can see this angle to be 34 degrees. Using values in geometrical regions, complete these statements to know that CB is actually parallel to OT. So CB is going to be this line. It's parallel to this line OT. So you'll have to prove them up. So let's just have a look at it. So you have a lot of reasoning to give here for 6 marks. So let's just go one step at a time to understand this further. Won't complicate you guys with too much explanation here. We'll just go one step at a time to understand this in much more detail. So first, the first statement says in triangles AOT and BOT, OT is common. So let's just real quick look at the triangles. This is your triangle AOT, and the other one is BOT. That's your triangle. And yes, we do notice that OT is the common length. Now he's saying angle AOT and OBT are 90 degree. Okay, so this angle and this angle are 90 degree. And we need to give a valid reasoning for that as to why these are 90 degree. So this is straightforward. We have a 90 degree here and we have a 90 degree here. And this is because tangent, do not forget to use the word tangent instead of writing MAT or NPT, the name of the tangents. Write tangent and radius because you need to give a general reasoning. Meet at 90 degree or write are perpendicular. Both reasoning are fine, but the keywords that you cannot miss out on in this reasoning is tangent, radius, and 90 degree or perpendicular. These are the keywords that you cannot miss out on. Okay, so Next up is that AT is equals to BT. Now what's AT? So this length is AT and this length is BT. We need to give them a reasoning as to why they are actually equal. So this is the case of tangent kite. You can see a kite being formed. This is the kite that we have. When you have two tangents, this is the kite that we have. When you have two tangents crossing the circle, you have a tangent kite. And in a tangent kite, this length AC, AT, and BT are actually equal. We can actually prove that using the right angle or the Pythagoras theorem as well. They are equal because they are tangents to the circle from the same point, which is the point T. So the reasoning should be here. What we are going to write as the valid reason as because the two tangents to circle are from the same point. So yeah, that's the valid reasoning is the key word here is that they are from the same point. You have them as the same point. The two tangents to the circle are from the same point, and that's why this AT and this BT are going to be equal. Okay, let's read further. So triangle AOT is congruent to triangle BOT. Now what does congruency applies? That they are exactly the same. Because of a congruency criteria, what should be the criteria as to why the two triangles are equal? So this will require you to have some basic knowledge of congruency criteria as to what are the criteria that you have for congruency. So namely, you have the side, the two triangles having all the three sides same are also called congruent. You have the side angle side, you have the angle side, and you have the right hypotenuse side. These are the most common four ones that are used. Okay, now which property would be applicable here? For that, we need to see the two triangles AOT and BOT. So this is AOT and this is BOT. Why are they congruent? So ideally, when you have a right angle hypotenuse side, this means the 90-degree right angle. So when you have a right angle, you ideally go for RHS, making sure that all the conditions are being satisfied. So it's a right angle, so that's 90 degrees being satisfied. Hypotenuse should be the same. You see the hypotenuse is actually the same. So that second condition satisfied. And you have to have the OT is the hypotenuse, so that's same. And you have to have the any other one side to be the same. And we do have this side, OB and OA, because they are radius, they're also same. So all the three conditions of a right hypotenuse side congruency criteria are being satisfied. So it's actually supposed to be RHS. We are just supposed to write the congruency criteria here. And the next part or the next portion, angle AOT and BOT is equals to 56 degree. So let's figure out which angle is given, AOT and BOT. So this is 56 and BOT, this is also 56. Yeah. And what are we supposed to calculate? They are the same 56, 56 because angles in a triangle add up to 1. Angle BOC now is what we are supposed to calculate. So, yeah. So these 56 are basically found by subtracting 180 minus 90 plus 34, the other two angles that we have here, this one and this one. So we're getting 56. That is what they explained. That's why the third angle in both the triangles is 56, because all the sum of angles in a triangle is 1. Now he's asking us to calculate the angle BOC and also write the reason for that. BOC is actually going to be this angle. Now for this angle, you need to have a look at the fact that it's a complete straight line. And on a straight line, you have the entire sum of angle to be 180. And we already know the two portions of it are 56, 56. So if we subtract them from 180, we get the remaining portion, the one value. So using that analogy, let's just calculate this here. It's going to be 180 minus 56. That's 56. That's 1112, and that should be 68. And so this is 68. And the reasoning for that is because all angles on a straight line add up to 180. So we're basically using the 180 logic that we found because it's a straight line. What we figured it out was that's a straight line. COA is a straight line. That's why the sum of angles on this should be 180. Now, so make sure you write the keywords and the important reasoning in this type of question. That's usually part of the examiner or the marking scheme that students miss out on keywords. The angle OBC, so that's going to be this angle. Now this is straightforward. If you remember the start of the question, we figured out that OCB is isosceles, and we know the other angle. Both these angles are going to be the same. So I'll just do 180 minus 68, and I'm getting 1112. I'll just divide that by 2 because I know the other two angles are just straight up same, which is going to be 56 degree. So both these angles are just going to be 56 and 56. So OBC is going to be 56. And the reasoning for that, you have an extra line here because you'll have to write two reasonings actually for this as to why this is 56. First thing is that we figured out that it's an isosceles. So that's why we just subtracted from 180 and divided by 2. Both the angles are equal. So because OCB triangle is isosceles, so base angles are equal. That's one reason why the other two angles are 56. And sum of angles in a triangle is 180. Okay, that's the reason why we subtracted from 1. And lastly, the last portion, CB is parallel to OT, finally at what it started. As to why they are parallel, the reason for that is, okay, now, so we initially ignored this, but let's look at this condition, what they're trying to prove here. So we have this as CB and this as OT. So CB is like this and OT is like this. I need to prove the lines to be parallel. Now, what do we know about parallel lines? Like, what have we learned in angle properties of lines is the types of angles that we know about, the Z angles and the F angles, with the actual names as corresponding and alternate and corresponding angles. So let's say we have two sets of parallel lines. This and this angle are equal, so that's alternate angles. And let's say we have situation like this maybe, and we have this angle and this angle equal, that's corresponding angles. And we also have interior angles, but these are the most commonly used properties with parallel lines. So somehow, if I can prove that this angle, and this angle are same, I can see the z being made alternate angles. I'll automatically prove that they are actually parallel lines. If I can somehow prove that the two angles, which we have already proven that they are 56 and 56, which you can see, are actually equal. So we can prove that they are parallel lines because these are alternate angles. The angle OBC and the angle BOT are actually both 56 degrees. So that is what we are supposed to prove here. So we'll write that CB is parallel to OT because now we need to write the names of the angles here. Do not miss out on the names of the angles, otherwise the examiner might get marks. So it's going to be OBC, the angle OBC, because OBC, and the angle BOT equal to BOT are both equal to 56 degree because they are alternate angles between parallel lines CB and OT. So the angle OB and BOT are both equal to 56. They are alternate angles in parallel lines, and that proves that the lines are actually parallel. Yeah, so that sums up our entire circle theorem question. Let's move on. Okay, so let's start with question 5, part A. ABC is a scalene triangle. A scalene triangle is having all sides different length. All sides have different length. So you have a ABC as a scalene triangle on horizontal ground. Why is this information relevant or important? We'll just get to know that in a minute or so. We'll discuss that. AYX is a straight vertical post. So this is like the base because it's on horizontal ground. So ABC. And this is like a pillar vertical post that you have here, held in place by two straight wires, XB and YC. AC is this, and you have all the relevant lengths given and angle given. Calculate AB. So where is AB? So this is AB. We're supposed to calculate that. So let's just take out that triangle real quick. So you have a situation like this. Maybe you have A, B, C. This angle is 20.4, 4.8, and 5.6. And we're supposed to calculate this length, AB. Now, the best way to do or go about this is to see it's trigonometry basically, and this is a scalene. That means it's not a right angle triangle. Now, for trigonometry, because what you do need to know is that when you have a right angle, you either go for Pythagoras theorem or you go for SOHCAHTOA, also known as trig ratios. These are called trig ratios, sine plus tan, or you go for the Pythagoras theorem. When you do not have a right angle triangle, not right angle triangle, so any other triangle which is not a right angle triangle, you go for the sine rule or the cosine rule. Here we do not have a right angle triangle, so we are actually in a situation of either of the two. How do we decide to use the sine rule or the cosine rule? Is by looking if we have one pair of angle and side complete. So we have that 20.4 is the angle, but the side opposite is the side corresponding side is the one that's opposite to it's missing. 4.8 has the side, but the angle is missing. 5.6 has the side, but the angle is missing. So apparently there is no angle side pair, no angle side pair completely given. Completely given. Hence, use cosine rule. So we are going to use the cosine rule here, because if we had a one angle side pair given, we would have used the sine rule. So we're going to use the cosine rule. So let's just apply that up here. So formula for cosine rule here, because we are looking for the length, so we'll use the length version of the formula. So that's a squared plus b squared plus c squared minus 2 times b times c times sine of a. Or you can switch around with the variables as well, like some people actually use, or let's just keep it like that actually. It's just for your understanding purpose, you get this right, that what you do need to make sure is that this side has to be that side that is actually corresponding to this angle. So the angle in this question is this one. So you'll have to take the side A to be this question mark side, which is AB. And that's perfectly spot on, because that is the side that we are looking to find out is AB. So this is just gonna be, let's just call it AB square, because yeah. And B and C are irrelevant as to like which to take B and C. It's just the other two sides. What was important is that this angle having this as the corresponding side. The capital letter or the uppercase letter is telling the angle and the lowercase letter is telling the side. Do not confuse it with these letters here, because those are just labeled in the question. And this formula is the general formula that we use. So do not get confused with the letters. Just have the concept strong that the angle here has to be that is corresponding to this side that you're finding out, or vice versa. Anyways, so that's this going to be AB square. The other side is going to be 4.8 square plus 5.6 square minus 2 times of 4.8 times 5.6 times sine of, actually it's going to be cosine, my bad. It's the cosine rule, so it's actually cos. So it's cos A actually, times cos, and the angle that we have is actually 20.4. And next up, what we can do is we can just copy this entire thing. Let's just write it here. And we'll just square root it. Because we have AB square, we need AB. So we'll just do square root of the entire thing. And then just put it in one go in the calculator, so we do not have any accuracy errors. So a square root of, start with square root of 4.8 square. Make sure to use brackets when squaring, so you do not have any mistakes, especially when you have a negative number. Minus plus 5.6 squares minus 2 times 4.8 times 5.6 times cos of 20.4. Bracket close, and we're getting it to be 2.0029, and the three significant figures are just going to be 2 as the final answer. This is where we stop. So you have 2 meters as the length of AB. So you're supposed to use the cosine rule for this part. Next part, we have the angle XBA. So that's XBA is going to be this angle. That's given as 64 degrees. You're supposed to calculate AX. So you're supposed to calculate this length. So you'll just plug out this triangle just the way that we plugged out this triangle. So it's going to be something like this. We know this to be 64. We know that this is the right angle triangle, XBA. And we're supposed to calculate this length, AX. What else do we know? Do we know AB? Yes, we found AB in the last part. So we know AB. AB is going to be 2. Or if you'd like to take a more accurate value, we could use 2.0029 from the previous answer. That is the value of AB that we have. And now we need AX. Now you have a right angle here. So when you have a right angle triangle, you go for Pythagoras theorem or SOHCAHTOA. We are gonna go for SOHCAHTOA over here because we have an angle involved. When you have an angle involved, that's the best choice. Pythagoras theorem is the one that's used when you have just lengths involved. We have an angle involved here, so we'll just use SOHCAHTOA. And now, which trig ratio should we use? We have the angle as 64, so that's 64. What else do we have? We have this as adjacent because it's between the angle and 90 degree. So it's actually adjacent. This is adjacent that we have, and the one that we are trying to find out is opposite to the angle, so it's actually opposite. So we are needing opposite and we have adjacent. So which trig ratio has opposite and adjacent? 2R. So that's your. So you're supposed to apply tan 64, or let's just write the formula. Tan theta is equals to opposite over adjacent. And that's tan 64 over opposite is the one that we are trying to find out. Let's just call that AX. And adjacent is going to be 2.0029. And AX is going to be tan 64 multiplied by 2.0029. So tan 64 times. So AX comes out to be 4.105, and let's round that up to 3 significant figures. So round it till here. So 6 is going to give it 1 carry to the 0, so that should be 4.1 as the final answer for AX. Third part, AY is given as 2.9. Calculate the area of triangle YAC. So let's check where is AY. So AY is this length. It's given out to be 2.9. And we're supposed to try calculate area of triangle YAC. So YAC is this triangle. Let's just plug that out real quick. That's YAC. We have a 90 degree here. YA or AY is actually 2.9. And do we know any other angle? We know AC to be 4.8. Now, for area, you have two methods that we can work around with, or two formulas. That's half into base into height, or half into A into B into sine C. Capital C is implying that's an angle. So here we can just work around with the first one because it's straightforward. We have base as 4.8. How do I know that's the base? Because I'm taking 2.9 as the height and they're both perpendicular. So it's actually vertical height, and perpendicular to that is the base on ground level, which is 4.8. So straightforward, gonna be this. You could have used the other one as well, by implying that the angle should be this, should be 90 degree. So would have gotten the same answer either ways. So half into 4.8 times 2.9, that's going to be straightforward 6.96 exactly. Meter square. Next part B. So in triangle PQR, M is the midpoint. So we're looking at the entire triangle PQR. M is the midpoint. So since this is the midpoint, so PM is going to be the same as MQ because M is the midpoint. RM is this, calculate PQ. Now we need PQ. So we need the entire length PQ. This is the length we are looking for. Now, the only thing for now that we can figure out that is that somehow if we figure out PM or NQ, we can just times it by 2 and we get the entire length using this analogy because M is the midpoint, so you have the same length PM and NQ. So if you get either of the two and you just times it by 2, you will get PQ. Now let's try to work around with trigonometry. We do not have right angles here, so we'll either be using sine root or cosine root, unless we have a right angle triangle. It seems very unlikely, so we'll most likely be working around with sine root or cosine. Now, for starters, what we can do is I see a straight line PQ, so I can just figure this out straightforward. This is just going to be 180 minus 75, because straight line has the sum of angle as 180, so that's 105. And since PRM is also a triangle, so sum of angles in a triangle is 180, so I can figure out the third angle if I know the other two angles. So 180 minus the other two angles, which is 30 and 105. That's 135, so that's going to give us 45. And now, if I look at the triangle, how do I find PQ? So best way is that I find either of PM or MP. And since now I've worked more on the triangle PRM, so I'm just going to plug that out. So we have a situation where we have P as this, R as this, M is this. This is 105, 45, and 30. Rm is 8 centimeter, and we do not know PM. And that is the purpose, that is what we are looking to find out, is PM. Because if we somehow find PM here, we can just times it by 2 to get PQ. So this is a non-right angle triangle, so we'll just use either sine or cosine rule. So now the thing, how do we check which one to use is, do we have one angle side pair complete? So we do have one angle side pair complete. So it's going to be sine root. Because we have sine 45 and the corresponding side to that, which is 8. So it's just going to be sine 45 over, or let's just keep the angle in the denominator. You can work around with both the formulas. Like some people prefer this one, where the side is in the numerator, or you could keep the angle in the numerator and the side in the denominator. Both work perfectly fine, but why I switched around with my formula and kept the side in the numerator? Ideally, you keep that thing in the numerator that you're trying to find. So we're trying to find a side, so that's why I kept the side in the numerator. Equals to PM is the side that we're looking for. Upon the corresponding angle to this is sine 30, and now we can just multiply PM times sine 45. Just cross multiply here. And 8 times sine 30. Then we do PM equals to 8 times sine 30 and take the sine 45 on the side, so it will actually divide. It's been multiplied here, so it will divide. So, and then we can use the calculator in one go. So that's fractions, 8 times sine 30 divided by sine 45, whole thing divided by sine 30. So I'm getting 5.65685. You can just do that times by 2 to calculate what was it, PQ, yes. So PQ is just going to be 2 times of PM. So that's just going to be 2 times of this. So I'm just going to use for accuracy purpose, use the answer in calculator and just times it by 2. So I'm getting 11.3137. So that's just going to be 3 significant figures. So that's just going to be 11.3 as the final answer. And that's 5 marks for this point. Okay, next up we have the cumulative frequency. Cumulative frequency is running total, in other words. They keep adding as you move forward. So it's actually known as running total. Table shows information about the speed of each of 200 cars. So you have a total frequency of 200 or total data values of 200 as they pass a speed camera. So they're actually showing the speed in kilometer per hour, and you have the cumulative frequency here. The first part is asking you to draw the cumulative frequency diagram. So you're supposed to draw the cumulative frequency diagram here. Now, the best way to work around with this is a 3 mark part, if I'm not wrong, yeah, is to treat them as x and y coordinates. So you have the x and the y coordinate. So this is just 70 comma y, in other words. This is 80 comma 46, 90 comma 115, 95 comma 155, and that's 100 comma 177, and 120 comma 200. And those are all the 6 points I need to mark, and then just drawing them up with a cube, with a curve, with a pencil. Use a pencil for diagrams, and you're good to go. The curve should be smooth though. So let's just mark them up. So 70 comma 12. Now we need to read the scale carefully here. Understand the scale for both of them. So let's understand the scale here. So I have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes representing 20 units. So what do I know about one box? One box is representing 2 units. So each box is representing. Similarly, I have a distance of 10. That means 10 units being represented by how many boxes? 10 boxes. So this one is more straightforward. One box is representing 1 unit. So keep a check on this. Here you have one box representing 1 unit on the x-axis, and on the y-axis you have one box representing 2 units. Now, the first value, let's start plotting them up. So the first value that we do have is 70 comma 12. So 70 is here, the x coordinate, and 12 is going to be, since this is the midpoint of 10, so that's going to be 12. Next up, we have 80 comma 46. So 80 comma 46, since each value is being represented twice, so this is 40, 42, 44, 46. Make sure to check the scale correctly. This is 80 comma 46. Next up, we have 90 comma 115. So for that, we'll have to zoom out. 115. So now we have 102, 104, 106, 108, 110, 112, 114, and 116. So 115 is going to be in between both of them. Next up, we have 95, 155. So 95 comma 155. 95 is going to be 92, 94. So 95 is going to be between the two lines, and y coordinate is 155. So yeah, so 155 is going to be 150. That's 152, 154, 155 is this, and it's going to be around here, if I'm not wrong. Let's check the value again. It was 95. So 92, 94, yeah, 95 and 155, because this is 152, 154. This is 95. The next value we have is 100 comma 177. So this is the line for 100, and 177. This is 178. I'm going backwards from 180. So 177 is in between. That's going to be 177 comma 100 comma 177. And lastly, 120 comma 200. So that's 120 is the last line and 200 is the last as well. This one. And now we have all the points marked. See, we can just join them up using a curve and we're good to go. Now, the key here is that you make sure it's a smooth curve. Yeah, it shouldn't be a line. Let's get that right. Hold up. Okay, yeah. So that's how the curve is going to look like. Try to just make sure it's not straight lines. It's actually a curve, and try to make it much more smooth than I have, ideally, and make sure that it passes through the points that you're marked. Okay, so the next part says use your cumulative frequency diagram. So you're actually supposed to use the graph here to find an estimate. It's going to be an estimate, obviously, because and since for that reason, your answer in the marking scheme will also have a particular range in between which the answer is acceptable. So the answer might differ for each of the students, but it must be in the given range in the marking scheme. So for the first part, you're supposed to calculate the median. Now for the median, the formula that we used in the stem and leaf question was n plus 1 over 2. But here we'll actually not do n plus 1, we'll just do n over 2. Because on a cumulative frequency curve, you just do n, not n plus 1 in each of the formulas of median, upper quartile, and lower quartile. So everywhere in the else, it's n plus 1, the formula, but here on cumulative frequency, it's just n over 2. And for upper quartile and interquartile, because that's going to come in handy in the next part, it's just going to be 1 over 4n and 3 over 4n because 25% and 35%. So, or other words, you can understand this as 50% of your data and your total values are actually 200. So 50% of your data is going to be 100, or you could have just done 200 over 2. That's 100. Now, what you need to do is you need to use your scale and keep it at 100. And check for the corresponding value. That's the corresponding x value that we may have. So we're getting somewhere around each box was representing 1 unit here. So that's 89 and 88, somewhere around 89 and 88. So let's call that 88.5. So the median that we are marking here is going to be, when I check the x-axis for it, that's how you use the graph. You're getting 88.5. So make sure to check the x-axis. That is what we did here. Similarly, as we are trying to find the term in stem and leaf, we found the term number and then we looked at the term that was the answer. Here, the answer for median and for upper and lower quartile are going to be on the x-axis. So do not forget to check the corresponding value against that. So the answer is not going to be 100 actually. It's actually going to be 88.5. You check against that value. Similarly, for interquartile range, now we know that for simple range, the formula is max value minus minimum value. But for interquartile range, the formula is upper quartile minus lower quartile. That's your formula for IQR, which is upper quartile. You need to find them out, each of them. Now, upper quartile is how much of your data? 75% of your data. So, upper quartile is 75%. So either you can take 75% of 200 or you can use the formula method, which is going to be n over 4, which is the same thing, or 1 over 3 over 4 actually. 3 over 4, that's 75% of 200, which is the same thing. So either ways, you're going to get what? 150, I think. 3/4 of 200 is going to be 150. And at 150, we'll make a line. Yeah. So approximately, we are getting somewhere between 92 and 93. So that's 92.5. Let's call that 92.5. For the upper quartile, we are getting the answer to be 90. Make sure we to check the y-axis, x-axis against the y value that we got. Because you found total frequency was 200, so you found the 75% is 150. Now for lower quartile, it's actually 25%. So that's 25 over 100 into the total, which is 200, so that's 50. So we are going to check against 50. 50 is here. So we're getting somewhere around 81. And when you subtract them up, so we'll get 11.5 as our interquartile range. Let's check for the answers. Do we have that in the acceptable range? So we have the median in the acceptable range for this. The marking scheme says you can have it between 87 to 89.5. So that's fine. But I think for the interquartile range, we have the answer to be between 12.5 and 14. So let's do this one again. We have an accuracy error, most likely because of not having the correct curve or not taking the correct corresponding values here. Yeah, this is approximately 93, let's say, against 150. And for against 25, 50, 25%, you have around 80. So that's going to give you the answer to be 30. So let's say we take this to be 93 and this to be around 80.5. So you get the answer to be 12.5. Just make sure to do this correctly so you lie in the correct range. The answer is going to be 12.5. Let's, yeah, that looks more accurate. And for this one, let's move it slightly to the right. Yeah, perfect. Okay, so this is 80.5, this is 93, and when subtracted, they'll give us 12.5, which is just in the range of 12.5 to 14. Yeah. And then next up, the number of cars with a speed greater than 110 kilometers per hour. Now he's asking for a number of things here. Keep a check for this. Number of things usually have the answers on the y-axis. So you have the answers for number of things on the y-axis because it's frequency. And on the x-axis, you have the answers for median, upper quartile, lower quartile, and so on and so forth. All of the other things are on the x-axis majorly. More mean they all have the answers on the x subject matter of the whatever the experiment is being done upon. And for number of things, frequency is the answer. So we need what exactly number of cars that have a speed greater than 110. So we'll go at 110 kilometer per hour. That's here on the x-axis. And we'll make a line that's going to be a long line. Okay. And then we're going to check against that line. So the value that we are getting here is, since each box is representing 2 units, so this is 190 and this to 192. So getting 192, but the answer should not be actually 192, it should be uh, 200 minus 190 because you need greater than 110. So since this is cumulative frequency, so all the cars with a speed less than 110 are actually 192 because it's a running total and it's in the lesser equal inequality always. Like the cars less than 110 speed are 192. So more than would be just total minus 192. That's 8 cars. That's your answer for this part. Next up, you have the frequency table here and shows the information about the mass of 50 trucks. So that's a total 50 values. And we're supposed to calculate the estimate of the mean. Now, why is this actually called estimate is the reason for why as to the exam is using estimate is because we know that we have 12 trucks, because we have trucks in the question, 12 trucks have a mass between 2000 and 2600 kg. But we do not know which truck has how much exactly in these 12 trucks. So we'll have to use the midpoint to average it out here. So we'll make a column for midpoint. You could say midpoint bracket x. The midpoint of this is 2300. How do you find the midpoint? Is you add the two quantities and divide them by 2. This is going to be, let's do this here so you understand, 2600 plus 3500 upon 2. And you can use the calculator just to be sure so you do not make a mistake. How do you find the midpoint? Is by adding the two quantities and dividing by 2. Same thing as taking average of 2 things. That's 3050. That's going to be 3500. The next one plus 5000 divided by 2. That's 42500. Just to be sure on that. Last up is we have 5350. The midpoint. And now you have the midpoints. Now it's going to be straightforward. We need to know the formula from mean. In our range table data, this is a range table data. It's just sum of fx divided by sum of f. Sum of fx is just f into x. So that's this frequency multiplied with x, which is this. So it's going to be 12 times 2300 plus 15 times 3050 plus 16 times 4250 plus 7 times 5350. And whole thing would be divided by sum of frequency, which is just the total number of values or the total of frequency with respect to. And then you can just use the calculator. You have shown the working for it. You can use the calculator to plug this in. Make sure to put in correctly and do not mix up the multiply and plus sign. Inside the bracket you have a multiply, outside you have a plus. So that's bracket open 12 into 2300 plus 15 into bracket open 15 into 3050 bracket close plus bracket open 16 into 4250 bracket close plus bracket open 7 into 35350 and then whole thing. Either you can add them up, get the answer, and then divide by 50, or you can just do that in one go as well, like I did. So that's going to be 3576 as the mean that you get for this answer. But make sure you do show your working because this is 4 marks. Let's say you made a mistake in the calculator somewhere around and you not have working, so you'll lose out on the marks. Next up, we have a histogram showing this information. Okay, so the previous data is being still carried forward upon a histogram, and the height of the first block is 6 centimeter. Calculate the heights of the remaining. Okay, so we do not have a histogram here, like in a diagram visual form. We just have certain data related to it and to calculate the height based on that data. Now, you need to have some basic idea of what the histogram looks like. Yeah, so that's what it basically looks like. But importantly, what you have on the y-axis is the frequency density. And this is whatever your subject matter is. In this case, it's going to be mass, because we have mass at x kg. Yeah, so you have x-axis as the mass, and y-axis is not frequency, it's actually frequency density. So the height of the first block, as in the first bar, the block is being referred to the bar here, the first bar. Each one, I can say, is actually 6. And what is the height on histogram? You notice what's the height being represented as? It's actually frequency density. So frequency density is actually 6 for the first block. And now we need to know the formula that connects frequency density, frequency, and class width. So the formula that we should have knowledge of prior to this is that frequency density is just frequency divided by class width. Now, what's class width? Class width is just the distance between your ranges. So that's for the first column, the class width is going to be 600 because 2600 minus 2000. For the second, it's going to be 3500 minus 2600. That's 900. That's your class width. In other words, B minus A. B is the greater range or the max range, and A is the minimum range in a double inequality. Now that's the formula that we have. And if you look at the first block, the first column, the data set tells us that the frequency is 12. So FD should have been actually, what the FD should have been actually was 12 frequency, and the class width is 2600 minus 2000, which is going to be 12 over 600. Now, which is in decimals 0.02 or 0.02. Now we need to know that the frequency density we have gotten is 0.02, but on their scale it's actually 6 centimeters. So what is the multiple they are using is, how do you go from 0.02 to 6? Is you can just 6 divided by 0.02 on the calculator. So you know how you are actually doing. You get 300. So you're basically multiplying your answer by 300. So you multiply by 300. And that's how you go from 0.02 to 6. That's what you're doing. Now, ideally, we'll actually try to use the fraction form of these instead of the decimals for more accurate answers, because we might have recurring decimals or we might have non-accurate answers in decimals. So fraction is the best way to go on this side, this type of questions. Yeah, so 12 over 600 is going to be multiplied by 300 to get 6. So whatever frequency density we get for the remaining blocks, because we are supposed to calculate the height of the three blocks, we just multiply it by times by 3. So now I'm going to do frequency density, or let's just say height. Height of second block is going to be frequency, that's 15 of the second column, over class width, which is going to be 900, and you times it by 300 because you need to time it by 300 to get the answer, which is going to be 5. The second block has the height 5. Height 3 is going to be 16 over 1500, that's your class width, times 300. That's 16 over 1500 times 300. That's going to give us 3.2. Yeah, accurate answers that we are getting. Otherwise, if you had used the decimals, 16 over 1500 actually in decimals is giving a recurring decimal of 6. Yeah, so best thing you need to do is that you use fractions here and not decimals, so your accuracy of your answer does not get uh, spoiled. So third height actually, height of the third block is 3.2. And lastly, the height of the fourth block is frequency 7 over class width, which is 5700 minus 5000, which is 700 times 300. That's your multiple. That's going to be 7 over 700 times. That's going to give us 3. Yeah, so 5, 3.2, and 3, those are the heights of the remaining 3 blocks. The first one was already found for us. Okay, next up is a diagram that shows the graph of a function. Put a ring around the word which correctly identifies the type of function. Okay, so we have 5 choices and we need to tell which function is it. So let's use the elimination method to understand this more in detail. So it's not going to be a linear. Let's just cut that out straightforward, because linear has a line instead of a curve. When you have a linear graph, it's a line. It's not a curve. So we have a curve, so it's not going to be linear. Now let's cancel out other options. It's not going to be quadratic, because quadratic either has this u, which is the happy face, or this has the sad face. Does not have a mixture of both of them, so it's either the happy face or the sad face. So it's not going to be quadratic either. It's not going to be reciprocal either, because for reciprocal functions, we usually have something of this sort. So it does not look like that either. And it's not going to be exponential either, because you have something of this sort or the other way around. And apparently we do not have that either. It's actually going to be cubic. That's your correct answer for this part. And another identification why this is a cubic graph is having multiple stationary points or turning points. That's one end of it having a cubic graph. Now, maximum point where you have. So this is a cubic graph. Let's move forward. Okay, in the next part, you're actually supposed to sketch the graph of y equals to 1 over 2x. Now, this is what type of function is this? It's actually a reciprocal function. The one that we just discussed here, the reciprocal function, the shape of it. The reciprocal graphs are fraction based. Fractional based. Those are your reciprocal functions. Now, if you do not have an idea how to sketch this, the best way you can work around this, make a table. So make a table for x and y values. So it's best to take negative values and positive both. So let's work around the -4, -2, 0, and then we can have some positive values. Now you can either use the table function on your calculator to real quick get the values, or you can just manually put in each of the values. You can just manually put in each of the values. So when you plug -4 in this equation, 1 over, so what I'm doing on the calculator, I'll just show is I'm doing this on the calculator to check the answer. So that's 1 over 2 times -4. I'm plugging -4 in place of x. I'm getting a negative 0. Yeah, let's do it without that. Yeah, so I'm getting a negative 0.125, and then when I plug in -2, getting a negative 2.5. And interestingly, when I plug in 0, it's giving me a method infinity or not possible. You do not have a value at x0, and that's also stated here as well. X cannot be 0. So none of the graph would be passing at the x-axis. And then at 1, getting 0.5. At 2, I'm getting 0.25. And at 4, I'm getting 0.125. Okay, that's the table that we have, and that is the one that we can use to sketch this graph. So now, guys, what's the purpose of having this table is why we drew this table to help us. And the reason why I wrote the answers in decimals instead of fractions is so for you to notice a pattern. First thing you have already noticed is that you do not have a value at x0. Similarly, you won't have a value at y0 as well, by the way. You try plugging y0 in this, y0. So when I have 0 over 1 over 2x, I take the 2x on the other side. So I can't solve this. You won't have an answer for this. So not possible either. Both y and the x-axis won't be touched upon by the graph because you do not have the value at x and y0. That's the first thing. Now the next thing is the pattern as to how the curve will go. Obviously, it's going to be a curve because it's a function, reciprocal function. It's not a linear line, so it's not going to be a line. The function will go up based upon how the values are happening. So let's say -4 is around here, -2 is around here, and to be more accurate, even though it's a sketch, let's say somewhere around here. Yeah. Your values of y, notice the pattern in your values of y is actually what? It's actually rising up, in other words. So you're actually going like this. Yeah, it's going to be the other way around actually, because the values are actually. Notice the pattern here. The best way you can compare the values is keep them in the same number of digits. So you can just add a 0 here. So 125 and then you have 250. So 250 means you're actually increasing your values as you decrease your x values. So as you move, how do you decrease your x values? You move like this. And your y values are actually decreased in the negative. So they're actually like this. That's how it's supposed to go according to the pattern as your y values, because you have the negative y axis are going in this direction. As your x values are decreasing, your y values are going in this direction. So that's going to be one part of the curve. And the positive side of it won't touch 0, by the way. It will get very close to 0, but it won't touch 0. That we have already discussed as to why, because there's no possible answer on x0 or y0, so it won't touch the x or the y axis. Let's draw this much more smoothly. And similarly, on the other side, it's going to be like this. And the reason for that is you notice your x values increasing and what's happening to your y values. So the best way to compare would be add up the same number of digits would be 3 zeros. So that's 500, that's 250, and that's 125. Just to compare them up, keep them in the same number of digits. How you can do that is just add a zero at the end. That does not make any difference. So what I'm trying to say is 0.5 is the same thing as 0.50 and also the same thing as 0.50. Or even if you could add 4 zeros, it still remain 0.5. You can add as many zeros as you want at the end. That actually helps us to compare here because we are just looking at the number after the decimal. So that's 500. Ignore the zero because that's common. So 500, 250, and 125. You are going from 500. You're actually going from 500, 250, 125. So you're actually decreasing. There's a decreasing pattern in your y values, and that explains as to how you have that decreasing pattern as you go along on the right. So your y values are decreasing as you increase your x values. So that's why the curve is going to look like this. So the final curve, I'll just shade that up with the red. It's going to be this and this, but won't touch the x axis or the y axis. That's your curve for this graph. Next part says solve the equation. Now he's saying solve and he's not asking us to use the graph here. So we just have to basically solve the equation without anything being referred to the graph or the previous part. So it's just solving the equation. We'll do that here. 1 over 2x equals to 2. So I need the x in the numerator to solve that. So I'll take the 2x on the other side. So it's just going to be 2x times 2x. That's going to give us 4x squared. Now, there are two ways I can work around this. Either I can take square root both sides. And when I do end up squaring both sides, so actually, how about we take the 4 on the other side first and then square root? That would be better. 1 divided by 4 as the 4 goes on the other side. Will divide because it was being multiplied here. Yeah, then you take square root both sides so you can cancel out the and when you do square root both sides, you have a plus minus on one side. That is the rule that you have. Whenever you square root by your own self voluntarily, so you have to add a plus minus on one side. And that is how you are actually going to get the two answers for this question. Otherwise, you won't get the two answers. You'll have the one negative and the one positive answer. You have to have a plus minus on one side of the equals to when you add a square root yourself. And then the square root of 1 over 4, you can use the calculator for that. So you're going to get 1 over 2. This is just the square and square root cancelling out. So that's just x. And it's going to be plus minus 1 over 2. So those are your two answers. That's 1 over 2 positive and that's 1 over 2 negative. Okay, next part up on the diagram, sketch the graph of y equals to sine x for this range. So which strict function is he asking us to sketch? The sine graph. We need to have the basic idea of the sine graph. It looks like this. The basic shape should be memorized. For reference purposes, now there are a million ways how you can work around this. Mostly with your calculator, the best way is you use the table function in your calculator. You write down this equation as it is. You write the start to be this, the end to be this, and step you use is 90. That's the normal step you use for sine. Step is telling you the distance between the values that you want in your x values. This is going to be 270. So you're using a distance of 90 here. That's why you plug in the step to be 90. And then you have the straight up the entire graph points, x and y coordinates. You can just plug in the points and you're good to go. So sine 0 is going to give me 0. So that's my point 1. Sine 90, so I have 90 here, is going to give me 1. Actually, you can check that using a calculator. Sine 180 is going to give me 0 again. Sine 270, that's 270 here, is going to give me negative 1. And sine 360 is going to give me 0. Have the basic graph for sine. Let's get this right. Yeah, try to make it much more smoother though, like this. So you get that right. That's your graph of y equals to sin x. Now next up, we have trigonometric equation solving for this particular range. So for that, for you to be able to solve this equation, there are certain rules. You need the SOHCAHTOA or the sine cos tan isolated with their coefficient being 1, which is not 1, which is 3, and the power being 1 as well. The power is 1, so that's not an issue. But we need the coefficient as to 1 and any other term as well that's accompanying to be on the other side. So the plus 1 should go on the other side. Let's just do that straight up. Take the plus 1 on the other side, that's negative 1. And then you need to isolate this 3 to make the coefficient 1 of sine x. So that's sine x equals to negative 1 over 3. Now you have it isolated. Now it's in a condition where you can do sine inverse to find the alpha. This is the alpha that I'm talking about, which is the basic angle. Now that's your sine inverse you do on your calculator, and you ignore the negative sign. That is, you do when you're taking out alpha, you ignore any negative signs. You just take out the angle as it is without considering for the negative. So that's sine inverse of 1 over 3. That's going to give us 19.471 degree. That's your alpha or basic angle. Now, we have gotten the alpha, but we still do not have the answers yet, because for that we need to use the grid method. We make the grid, and remember that's AST, all science teachers crazy, or add sugar to coffee, add sugar to coffee. That's how you remember this, that in the first quadrant, this is quadrant 1, 2, 3, 4. You have all positive, second quadrant sine positive, third quadrant tan positive, fourth quadrant cos positive. Now, since you do know that, how do you decide the quadrant in this question? So when you do decide the quadrant at this point, quadrant, when you have isolated the trig ratio and you're about to take inverse, that is when you decide the quadrant. So the quadrants in this question are actually based upon the fact that we have sine and we have sine negative. So that means the quadrant is sine negative. Where do we have sine as negative? In the third and the fourth quadrant. That is where we have third and fourth. Those are the quadrants we have, because sine is negative in the third and fourth quadrant. So you decide the quadrants and then you just make a line like this and line like this. Those quadrants, the quadrants that are relevant to your questions, and then you travel for the answers, for x answers, you always travel in which direction for the positive answers, since we are looking for the positive answers here. we travel in this direction, anti-clockwise direction. Yeah. So the first answer, hold up, I think we lost that. Yeah. So the first answer is gonna be when I travel from here to here, and this is just gonna be 180 plus. Okay, I think we did not mark the alpha, so let's mark that up first. That would be more correct way of doing this. Is we mark the alpha that we have here. So that's 19.471, 19.471. And how exactly do we mark the alpha here? It's always the acute angle with the x-axis, with the x-axis. So that's how I decide that this angle is going to be 19.47 because it's with the x-axis. This is my x-axis. And now we can find out the x angle. So the first x angle is just going to be 180 because this entire angle is going to be 180 till here and the angle till here. So that's 180 plus 19.471, comma. The other angle is going to be, I'm going to stop at the second line this time around. That's 360 because the entire circle is 360. So that's 360 minus 19.471. And then we can have the answer using the calculator. That's 180 plus 19.471. 199. And for angles, okay, let me just write that down first. 316 minus 19.471. That's coming out to be 340.529. Yeah, now for angles, you round up to one decimal place, not 369 figures, you round up to one decimal place per angle. So this is just going to be 199.5 because 7 is greater than 5, so it gives 1 carry to the 4. And this is going to be 340.5. Those are the final answers for this part. Question 8, part A. A shop sells the shirts for X dollar. So selling price is actually X for shirts. And for jackets, it's actually selling price is X plus 27 for jackets. The shop sells 4 shirts, so we have 4 of them, and 3 jackets for a total of 194.75. Okay, that's the total amount of money received by the shopkeeper for selling 4 shirts and 3 jackets. Write down and solve an equation to find the cost of one shirt. So this is easy because if he's selling one shirt for X amount, so how much would he be selling the 4 shirts for? 4 times X. Similarly, for the jackets, if he's selling one jacket for X plus 27, just do that 3 times because we have a total of 3 jackets. And the total amount, you add them up, the total amount we're getting, the total amount received is 194.75. That is the equation we're supposed to form. And now you're supposed to solve that. That's 4x plus 3 times x is 3x, 3 times 27 is 81, equals to 194.75. That's going to be 7x, 4x plus 3x can be added because they are similar terms. 81 goes on the other side. That's 194.75 minus 81. And then x is equals to 194.75 minus 81 divided by 7 because 7 was being multiplied. And then we can use the calculator fractions. 194.75 minus 81 whole thing divided by 7. So we're getting the price to be exactly 16.25. Do not round this off. This is an exact answer. $16.25 is your answer for this particular part. Next up, we have the simultaneous equations that we're supposed to solve here. So let's do that. The best way to work around here is to actually give them numbers. That's your equation 1, that's your equation 2. So that way we can recall them much more easily. So we are going to use the multiple methods we can work around with. We are going to use substitution method. So let's take which equation do we take? So let's take equation 2. And I'm trying to make y the subject, but that seems easiest. So that's 5x plus y equals to minus 7. So y can be isolated by taking the 5x on the other side. So it's just negative 8, negative 5x. And that's your substitution. You can call this 3. Now plug this in the first equation, the one that we did not use. Substitute the substitution that you made in the other equation, which is the equation 1. So that's going to be x squared. The equation 1 is actually x squared plus 4y equals to 37. And then I can substitute x squared plus 4. Now I'll substitute in place of y the substitution that I've made. Minus 8 minus 5x equals to 37. X squared, this is 4 times negative 8 is negative 32. That's negative 20x equals to 37. Rearrange them up. X squared minus 20x minus 32 minus 37 as it also comes on this side. Next up you have x squared minus 20x. This is minus 69 equals to 0. Okay, now we have a quadratic here. Ax squared plus bx plus c. That's your quadratic equation. Now there are multiple ways you can work around this. You can try factorizing. You can try the quadratic formula. Usually for the quadratic formula, when you have non-exact answers, so answers, you have a degree of answer specified, like you have to give the answer to 2 decimal places or certain significant figures, which is not in this particular case. So we can try to work around without the quadratic formula. Let's try to do it with the factorizing method. Yeah, so let's do it through factorizing. Now for factorizing, I have 1 here and 69 here. So that's 69, negative 69, and the middle term is negative. So I need to think of 2 numbers here that actually multiply to give 69, and the same 2 numbers either add up or subtract to give minus 20, which is the middle term. So factors of 69, I'm thinking for. So it's going to be 1 times 69. That's not going to help. 2 is not divisible by 69. So you have 3 times 23. That's your factor. So, and that's also going to give you 20. So that is the correct factor. So 3 and 23 and 3 and 23. Now, how do you make negative 20 is by taking a negative here and here. So yeah, 3 and 23. So that's going to be like this. How we factorize this is x squared. Now minus 20, how do you make minus 20 is minus 23 plus 3. That's how you get the minus 23 and plus 3 will give you the minus 20. Minus 69 equals to 0. Then you make pairs of 2 and you take out common. So that's x common, x minus 23. Similarly, for this bracket should be x minus 23. What do you take common to get that? Plus 3. Yeah. So that's the two factors you have are x plus 3 and x minus 23 equals to 0. Then you separately equate them to 0. X minus 23 equals to 0. X equals to minus 3 and x equals to 23. Those are your two answers for x. Let's see the answer space now. Yeah, negative 3 and 23. But you do need the y's as well as it goes along for simultaneous equations. Now, the best way to plug the best place to plug the x coordinates in would be the substitution itself. So we're going to use it in the third equation, which was the substitution. So y equals to minus 8 minus 5. First up, I'm going to use x as negative 3. So that's going to give me y equals to minus 8 minus 5 times negative 3. That's coming out to be minus 8 and plus 15. So that's 7. So minus 3 has the y coordinate 7. And similarly for x equals to 23, it's going to be y equals to 8, negative 8 actually, times negative 5 into 23. That's negative 8, negative 5 into 23. That's going to give us y as 123 as the y coordinate against the x coordinate 23. Those are your answers for your simultaneous equations. That's done. Let's move on to the next question. Okay, so we have a solid cylinder. Now, what's a solid cylinder? So the keyword here, solid means solid implies that the cylinder is actually from the top of the cylinder, it's actually closed. Cylinder is actually closed, like a can of any soft drink would be a solid cylinder because it's actually closed. However, a glass would not be a solid cylinder because it's actually open from the top. So top closed would mean that it's solid. It has the radius x, so that's your radius, which is equivalent to x, and your height is actually 6x, the height of the cylinder. A sphere, you have a sphere then with the radius r has the same surface area, so that's your key underlining here. Your surface area is same for the sphere and the surface area, total surface area of the cylinder. And you're supposed to show this. So what do we know so far? The total surface area of cylinder. First, let's try to figure that out. Our total surface area of cylinder. How do we know that? Is by when we look at the cylinder and we try to open that up, what is a cylinder basically? So cylinder is basically, in other words, a circle top, a circle base, and you have this curved portion, which is actually a rectangle. Yeah, that's your cylinder broken down part by part. So you'll have two circles. So two circles would mean since you have pi square as the area of one circle, so you're just going to times it by 2. So that's 2 pi square plus the curved surface area of the rectangle, which is the rectangle area of rectangle, which is the height is going to be 6x here. And this is actually going to be the circumference because it's actually curved upon. Circumference is actually 2 pi r because it's the grounding or the boundary of the circle here that's opened up to form this. So that's why it's going to be actually, yeah, 2 pi r. So you have the formula for rectangle as length into width. So that's 2 pi r times 6x, or the height, which is h, 2 pi r h. Actually, it should be h here. because we're trying to understand the general formula. This is the height, and that's your 2 pi r, because that's the circumference, the width. So it's going to be 2 pi r h. So that's why your formula for the total surface area of a cylinder is 2 pi r square plus 2 pi r h. This is for the two circles, rectangle. This is for the rectangle, the curved part. 2 pi r h is the curved surface area as well. Now, using that analogy, we can just fill in the values for the total surface area of cylinder. So that's 2 pi. R is actually given as x, so make sure you take x instead of r. Square plus 2 pi r, again x, and height is given as 6x. So when we solve that up, so we are getting 2 pi x square plus 12. 2 into 6 is 12. Pi comes as it is, and x into x is x square. And now I can add them up as well because they are of the same quantity, same subject family, you could say. Like x square can be added up. Pi is just a value there, 2 pi and 12 pi, so that's just 14 pi x square. That's your area, total surface area of cylinder. And it's the same thing as the surface sphere, same surface area as the sphere. Now, the surface area of sphere is, the formula is given 4 pi r square, so that's 4 pi r square, which is 4 pi, and what's the radius? The radius is supposed to be r only, so it's just going to be 4 pi r square, because we're using the value of radius as r only, so that's just the sphere. Now, what the examiner is saying is that this quantity, this value, and this value should be equivalent. That is what this line is telling us. So we'll just equate them up. 4 pi r square equals to 14 pi x square. Now you can straight up see the pi being cancelled out. What were we supposed to show this? We'll make r square the subject by taking the 4 on the other side. So that's 14x square divided by 4, as the 4 was being multiplied on this side. Then you can cancel them in the table of 2. 2 2s are 2 7s are, that's r square. So 7 over 2 x square. And that is what we were supposed to show. That's shown. Yeah, that's correct. Let's move forward. Okay, so question 9 part A, we have a diagram that shows a shape made from a square ABCD. So yeah, that's the square that we have, having all the 4 sides equal, so that would mean, and 2 equal sectors of a circle. So you have this as the sector and this as the sector. The square has side 11, so if this is 11, this is going to be 11, this is 11, this is 11. And since we have 2 equal sectors, as pizza slices, you could say possibly. So this sector that we have here will have A as the center point. This sector will have C as the center point of the circle, which means that AD is the radius, so AM is also going to be 11, because AM is also a radius, and BC and BN are going to be the same. Since BC is 11, CN is going to be 11 as well, because it's again a radius of the circle. Because radius is center to circumference. And now we are supposed to calculate the area of the shape. So the shape is the entire thing. So we are going to divide it into portions. The area of the square is just L square. So it's just going to be 11 square, or length into length, which is going to be 120. And for area of the sectors, so area of the sector, the formula that we have is where area of a sector is theta, that is the angle over 360 times the normal area of a full circle, which is from where the sector is basically being brought apart from the full circle when you break it down. That's theta over 360 into pi r square. That's your area of a sector. So considering theta here would be this angle, which is going to be actually 90 degree. And similarly, this angle is going to be 90 degree here. The angles are 90 degree here because uh, we have a straight line and AM and AD are actually perpendicular here. So they're making a 90 degree angle. So the theta in this case is actually going to be 90 over 360 times pi r square. R in this scenario is going to be 11. So that's 11 square. And since there are two sectors, so I'm just going to times 2 my answer. I'll get the area of both the sectors here. Area of both sectors. So that's 2 times 90 over 360 into pi. That's, we'll use the pi as the pi value, pi button on the calculator, I mean, instead of using any other value for it. And now we are getting the answer in decimals and in pi, but it's best to keep it in pi here. So we have a much more accurate answer, the final answer. So area of shape is just going to be the area of square, which is 121, plus the area of the two sectors, which is 121 over 2 pi. And when I add them up, so I'm getting 311.066. So 3, according to 3 significant figures, that's 311 as my area of the entire shape. Next up, we are supposed to calculate the perimeter of the entire shape. So it's like we have to travel from point M and reach at the point M again. So we'll be covering all the sides that come along, all the outer boundaries. So a keyword here is that sum of all outer sides. So it's not actually sum of all sides, it's actually sum of all outer sides that you may have. Yeah, so we are not going to take the sides AD and BC. So it's just going to be AN, that's 11. And then we have AB as 11 as well. Then we have the arc BC, arc BN actually, this arc BN. So let's rewrite that for now, arc BN plus 11 again for the CM, 11 again for the DC, plus the last arc is going to be this DM arc at the point where we reach the point M again. That means we have taken all the outer sides. Now we have gotten the 11s. Let's just add the 11s up. That's 4 times 11. That's going to be 44. So that's 44 plus arc BN plus arc BN. Arc length is the crust part of the piezo slice or the sector. This portion is the one that we're looking for. Yeah, now to find them out, it's going to be the same value for both of them. But the formula that we have for arc length is again theta over 360. You proportionate it because you're breaking the sector is just a part of a circle broken down. Upon the total arc would be the total circumference, which is 2 pi r. So you're proportionating on that basis. So again, the angle we have is 90 over 360, which is 1/4 of the circle, in other words, into 2 pi r, which is 11. And you do the same for that one as well. Or you can just do times by 2 also, that also works. But for method marks, this would be better that we show the entire working properly here. And then we can just use our calculator to do 44 plus 90 over 360 times 2 pi into 11. And then you can either add the same answer or times it by 2. So we're getting the parameter to be 78.558, which is three significant figures, 78.6 as the final answer, the parameter of the entire shape. Next up, we have a cube. A cube is basically the 3D version of a square. So you have all the sides actually the same, 7. So this is 7, 7, 7. All the three dimensions will have the length 7, 7, 7. Because cube is just a 3D version of square, having all the sides same. Calculate the angle between AG and the base of the cube. The base is a square base here, obviously. This A, B, B, C, and we need to calculate the angle it makes with AG. So first thing we need to do is we actually need to connect A and G here. Yeah. And now we need to connect them with the base. How do we do that? Is we connect the A, the same starting point, with the base point C. Using that knowledge, now we can figure out the angle between AG and the base is going to be this angle. And this is going to be a right angle vertically below that, also perpendicular. Yeah. So if we take out, plug this triangle out, so it's something like this. G, C, A. Supposed to calculate this angle. This is 7. This is going to be C actually. What is AC? We do not know AC, and we do not know the angle either. So we do not have enough data here to figure out the angle. But if we had AC, we could have applied SOHCAHTOA, because we have a right angle triangle and angle involved, so we'll apply SOHCAHTOA. So first we need to somehow find AC. So we have diverted our question requirement to AC first, and then we can work out the angle. So for AC, you can spot another triangle being made here, is this triangle. We plug that out, so it's going to be like this, C, D, A, with a right angle at B actually. CD is 7, AB is 7, so we have a right angle, so we can apply Pythagoras theorem here. Because we have sides involved, no angle, so we can figure out this last side, which is the hypotenuse in this case. So AC square is equals to 7 square plus 7 square. Pythagoras theorem, by the way, is A square equals to A square plus B square. So, and then we do AC of under root 7 square plus 7 square. Ideally, you should add brackets here. In case you have a negative value, you do not get that wrong. And then you can just do 49, 49. AC is 7 under root 2. We'll use the non-exact, we'll use the non-decimal answer here, so we have more accuracy. So 7 under root 2 is AC. Now we have figured out that this is 7 under root 2, and now we know two sides. So we can apply Pythagoras again to figure out, actually never mind, we need the angle here, sorry. We do not need the side, we need the angle. Now, what sides do we have? We have the opposite, because it's opposite to that angle. And we have the angle and 90 degree between. side which is the adjacent. So we have opposite and adjacent. And what formula, what ratio does opposite and adjacent are used in? So that's here. So that is your tan. So we'll have tan theta equals to opposite over hypotenuse. So that means we have tan of, let's call this angle theta x only. Let's call this angle x. So tan x equals to opposite, which is 7 in this scenario, which is BC, and adjacent is AC, which we found to be 7 under root 2. And now x is equals to tan inverse, because it goes on the other side, it will be tan inverse 7 under root divided by 7 under root 2. So that's tan inverse on your calculator, fractions 7 divided by 7 under root 2. And we're getting 35.264, which is equivalent to 35.3, because for angles we round them up to one decimal place. Okay, so question 10. The table shows the values for this equation graph. We're supposed to complete the table for the first part. Okay, so the best way you can do this, the fastest way, is using the table function. You have the calculator option available. So you use the table function, you put in the equation as 2 to the power x. You can have the x on your calculator. The keys 2 to the power x minus 3. And you place in the values from starting from -2 ending at 2.5. You'll get the values for all the relevant values that we need. Input in the step as the difference between each x value. You can use 0.5 as the step. So it will give you x values at the interval of each 0.5. Other way you can do is just manually. So I'll do the manual method here. Is that I just do 2 to the power 1 minus 3. So that's just straight up -1. So that's -1. If I wrote 2 to the power 0, that's 1 minus 2. Let's do that. Getting -2 here. 2 to the power 1 is going to give us, hold up, I think this is -1 actually, yeah. So this might be correct. Yeah, this value is incorrect here. This is going to be actually -2.5. For this exact reason, just make sure you use the calculator properly to plug in the values properly so you do not make a mistake. This is actually -2.5. This is -1. And I think that's all that we have to complete. So that's done for the first part. 3 marks, 3 easy marks, just for plugging the values of x. Now you are supposed to draw this graph. You have all the x and y coordinates, so you just need to plot the points and make the curve. It's going to be an exponential graph because whenever you have x in the power, it's actually exponential graph. Exponential graph or function. So we'll have a curve instead of a line. It's not linear. Let's just plot the points. So we have -2 and 2.75. So to understand the scale better, we have 10 boxes, each box representing how much? So 10 box representing 1 unit. So one box would be representing 0.01. So that's actually not 0.01, actually, sorry, 0.1. Yeah, that's 2.1, 2.2, -2.3, so on and so forth. That's your scale for the y-axis. And for the x-axis, it's actually 10 box representing 1 unit, which is the same scale actually. So one box presenting 0.1. And now we can plot the values. So the first value we have is -2 and -2.75. You can write them in the form of x and y coordinates. So you make sure you do not mix them up, like mix the y's and x here. So -2 and -2.75. So this is -2.5, this is -2.75. It's -2.6, 2.7, 2.8. So it has to be between the two. Next up, we have -1 and 2.5. So that's going to be this value. Zero and -2. So that's this value. 0.5 and -1.58. So 0.5 and -1.5 is this. 5.8 would be, since 1.6 would be this. 5.8 is somewhere around here. 1 comma -1, 1.5, 0.17. So 1.5 and 0.17 would be somewhere around here. Hold up, it's actually positive 0. Or negative. Yeah, so you're marking it right. And then you have 2 comma 1. And lastly, you have 2.5, which is going to be this. Which is going to be 2.5, comma 2.66. So 2.66, then 2.5, 2.6, 2.7, so 2.66 is around there. And then we can just join it up and make a curve. And then you can just join the points and we've gotten the curve. So that's done. Just make sure it's a smooth curve. Now, you're supposed to use the graph here to solve the equation. So this is like a must condition here. You have to use the graph. There's no other way you're doing this and getting the mark. Use the graph to solve the equation. This. Now, the way that you do such questions is that you look at your initial equation, find out the initial equation in the question was this. Only the right side of it, like without the y, is 2 to the power x minus 3. And try to find out the same in the requirement part. This is the same portion of it. So the only new portion that you have is this equals to 2. And now, since this is equivalent to y, so you replace the y in place of this. And again, this would be also equivalent to y. So what would this value be actually? It would be y equals to 2. Because that's how you would be equating both the y's. Why am I equating both the y's to solve? Because when do you equate? This is important to understand. You equate / substitute in simultaneous equations. Simultaneous equations. And what does simultaneous equation gives you? Points of intersection. That is very important to understand that simultaneous equation actually gives you points of intersection where the two graphs, not calling the lines, the two graphs, so can be a line or a curve, both intersect. That is the answers of the x and y coordinate where they're intersecting is what simultaneous equation gives. So equating the two y's, you should get the solve would mean the x answers and you equate both of them up. So that's how you would be equating both the y's. So one equation is y equals to 2x, 2 to the power x minus 3, the other is y equals to 2. So we already have the graph of 1, we need the y equals to 2 now. It's going to be a linear, so it's going to be a line actually, and it's going to be a horizontal line at the point of y value being 2. So actually, let's use a different color. Yeah, so that's your line y equals to 2. This is the graph for y equals to 2x power minus 3. Now, points of intersection is this point where they're actually intersecting. We need the x coordinate for this where they're intersecting. So let's just get that. So that's approximately around 2.3. Yeah, so the answer is 2.3 for the x. And next part, by drawing a suitable straight line, we're supposed to draw a straight line. Solve the equation this. Now this one is slightly more tricky compared to the previous one, and that's why the marks are 4, that was for 1. Again, but the method of solving remains the same as to how to attempt such questions. It's that you try to look out for that portion of the equation that's familiar to the equation that we have, 2 to the power x minus 3. So 2 to the power x minus 3, we only have the 2 to the power x here, but the minus 3 is missing. So somehow we need to get that minus 3 on the left side. So we need to somehow on the left side of it, it's the left and the right side. On the left side of it, we need to make the same equation, that's 2 to the power x minus 3. Now, how do we make that? Is we write this down to the x minus 1.5, and we do equals to 0. And what we do need to make this left hand side, this is the left side and this is the right side. We're working on the left side, we need the left hand side to be just having this equation of the graph, 2 to the power x minus this one. Now, for us to have this, now we need to backtrack. How do we go from here to here? How do we make this to this? So obviously we do not need the x here. So we'll do plus x. So we're gonna actually plus x because we are gonna remove the x, and we need to make minus 3 here. So to make minus 3, we would have to do negative 1.5. By the way, if we do plus x here, we'll have to do the plus x here as well, and a negative 1.5 here as well. Or in other words, you can understand that I'm taking the x on the other side, so it's going to become plus x. It's the same thing. And the negative 3 I need on this side, so I already have a negative 1.5, so I'll do another negative 1.5 because negative 1.5, negative 1.5 actually add up to minus 3. That's how I get the minus 3. And I'll have to do the same on the right as well to keep the equation as an equation equal on both sides. So whatever operation I apply on the left, I'll have to apply that on the right as well, whatever adjustments I do. So technically, so when I arrive at this, so this would be plus x minus 1.5. So it would look like 2 to the power x. So I've manipulated it in my way as this. The left side is finally now comprising of the exact same curve that we had in the question. So that's your first y because equivalent to y. And now the other y is this entire thing. So the equation of the other would be actually y equals to x minus 1.5, which is actually what? A linear line. And how do you sketch a linear line? I need to sketch that because I need to, by making a suitable line, that's also giving me the hint to use the graph. So for a linear line, we need two set of points. Actually any two set of points. So I'll just use x0 And I plug x0, so I'm getting y to be 0 minus 1.5, which is just minus. So that makes for 1 point to be 0 comma negative 1.5. And most common other point is y0. When I plug y0, I get x to be 1.5. So the other point I'm getting is 1.5 comma 0. Those are the 2 points. I can mark them up. So that's 0 comma negative 1.5. So that's going to be this point. And the other one is actually 1.5 comma 0. That's this one. And then I can just make the line. Okay, we have to actually extend the line fully here. So in order to actually check the points of intersection. Yeah, so that's going to be the line. The orange line is actually the line for y equals to x minus 1.5. And now we can find out, because we are supposed to solve as in find the points of intersection again. Because we have equated the y and y. So we need points of intersection actually. Substitution gives us point of intersection. So the curve, the green is the curve that we have, the exponential function, and the orange one is the linear line that we can draw. And the points of intersection that we'll have are actually two of them, this and this. So let's just real quick find out the values. So the values that we have here going to be around 1.6, 7, 8, 9, 10. So it's going 1.6, 1.7 actually. This one I've traveled up, but it's exactly coming out at -1. So we'll work around with one answer as -1 and the other answer as positive 1.7. Those are the two answers that we have got for this part. Okay, that's all for this question. Let's move on to the next part. Next question. We have the coordinates of n given and coordinates of n given. So we're supposed to calculate the length. Now the formula for length is under root x2 bracket open x2 minus x1 whole square plus y2 minus y1 whole square. It's under root the whole thing. Now we can just for reference mark this as x1, y1, x2, y2. So we do not make a mistake in putting the formula. So that's mn equals to, it's basically the formula is derived from the Pythagoras theorem itself. When we put all the points on the grid, we'll get understand that. So x2 is -2 minus x1 is 4 whole square plus y2 is -7 minus 1 whole square. That's 36. It is negative because now it's very important that you square it in the bracket. So it's actually 6 square, that's going to be 36. Otherwise, you would have gotten this, would have gotten you -36, which is incorrect here. Make sure you put it in correctly using the brackets when you're squaring, so the negative also squares out. This is going to be -8 square, again 64, and that's square root of 100, that's going to be 10. 10 is your answer, that's the length. You're supposed to calculate the gradient. The formula for gradient, the symbol we use for gradient is m, and the formula that we use is y2 minus y1 over x2 minus x1, or rise over 1, the same thing. Now y2, since we're using the same numbers, y1, so that's -7, because we're supposed to find the gradient of m and n only. So -7 minus 1 over -2 and -4. That should be the correct. -8 -6. So minus and minus cancel out. So we're left with 4 over 3 as the answer for part B. That's the gradient. Third part is much more interesting. We are supposed to calculate the equation of the perpendicular bisector of M. Now, keyword. We need equation, so we'll obviously use the general form here. We need to use the general. We need to know the general form, which is y equals to mx plus c. But now, interestingly, what's a perpendicular bisector? Any idea what's a perpendicular bisector here? And perpendicular bisector of MN. So first up is that we visualize this. That's the best possible way we can do this. Is we visualize as to M and N. Now the perpendicular bisector of MN is actually going to pass through the midpoint of MN. So what I'm trying to say is, let's label this point as X with a passing through. And this is going to be 90 degree. Why so? Because of this perpendicular means they're making the line perpendicular bisector is a line actually. It's going to be 90 degree to the other line, which is MN, which is it is. So the red line is going to be 90 degree, and bisect means by means 2, so it's cutting it into 2 equal halves. Cut into 2 equal halves. So that's why your mx and mn would be the same. So mx and xn, sorry, not mn. mx and xn would be the same because x would be the midpoint, x8 midpoint of mn. Why so? Because of the word bisector. That is what caused it at 90 degree because of the word perpendicular. That is the visual implication of what you understood. So to sum it up, this is the red line is actually the perpendicular bisector line of MN. And now we need the equation for this line, because that is what the question is asking. Find the equation of the perpendicular bisector line. So we need the equation of the red line, and for the equation of any line, we actually need the gradient and the y-intercept. So let's work around for the gradient first. Now we know the gradient of AB, sorry, not AB, actually NN. We know that the gradient for NN, the gradient for NN is actually found in the last part as 4 over 3. This means, this implies the gradient for the perpendicular bisector. So I'm going to call this line PB. Perpendicular bisector is going to be -3 over 4. Now there are multiple ways how you can understand how we got this -3 over 4 is the perpendicular lines, n1 that's greater than 1 times n2 is equal to -1. So if you do 4 over 3 times -3 over 4, you should get -1. You can check. Or negative reciprocal. There are two ways you can understand how So I just did the negative reciprocal. I reciprocated the gradient and I multiplied it with negative. So I changed the sign of it. I got the gradient of the other line because the two lines are perpendicular. So that's why I can apply this property because they are making a 90 degree. I've gotten the gradient. Now for the point, I need a point on the line as well. So I can find out the C by plugging the X and Y. So currently I have a situation where I have the equation looking like this. I placed the gradient, but I still do not know what's the C going to be. For that, I need a point, any point, or a point on the line. And the only point I know on the line is the point X actually. On the red line, not talking about the MN line because we need the equation of the red lines, is the point X. And what we know about point X, it's actually the midpoint of MN. So I can find out the coordinates of X. So X is just going to be midpoint of MN. What were the coordinates of M and N? So M was 4, 1 and N was -2, -7. We'll take the midpoint. So midpoint of the X coordinate is just X1 plus X2 divided by 2. And similarly for the Y coordinate, we do Y1 plus Y2 divided by 2. So that's X1, Y1, X1, X2 divided by 2. We can place them up, so we get X1 to be 4 plus -2 divided by 2. And that's 2, 2 over 2 is 1. And for Y coordinate, that's 1 plus -7, that's divided by 2. So that's -6 divided by 2, -3. So we're getting the midpoint to be, or the coordinates of X to be 1, -3. Now we have a point as well. We can place it in this equation to find out C. It's going to be Y equals to -3 over 4x plus C. Then we place the point 1 and -3. So that's -3 equals to 3 over 4 times 1 plus C. And we can say 3 is -3. And this goes on the other side. 3 over 4 times 1 is just 3 over 4. So that's, I can remove the 1. So that's -3 plus 3 over 4. That's going to give me C equals to -9 over 4. I finally have the value of C, so I can write down the equation now, which is going to be -3 over 4x minus 9 over 4. And we can write the same equation here as well as the final answer. You can take the denominator 4 common as well. That's also fine. Or you can just leave it like this as well. Both of the answers are acceptable by the examiner. So that's how you find the equation of a perpendicular bisector. Last up for paper 4 is the question number 12 that we have. We are given an equation of a curve and we're supposed to find the derivative, which is dy over dx of this curve. So how do you differentiate or find the derivative? Is very easy. You take each term one at a time. So we have x to the power 4. How it works is that it goes here and the power reduces by 1. So taking this to be here and then reducing by 1. So that's just x to the power 3. This is going to be 2 times of 8 is -16 and x power reduced is 1. Now for constant. Now constant is the same thing as x to the power 0 because 5 to the power 1. So that's, now 0 goes on the other side. So that's 0 times 5 is going to be 0. So the differentiation for constant differentiation is equals to 0. That's why you have a 0 here. And final answer is just going to be x cubed minus 16x as well. Sorry, it's going to be 4x cubed actually because 4 times 1 is going to give you 4. Yeah, so it's going to be 4x cubed minus 16x. Now, second part, find the coordinates of the three turning points. We have three turning points. Now, the concept here says that for turning points, turning point is the part where the graph is actually turning. So those are these points where graph is actually turning. And if you end up drawing a tangent here, you'd notice, if you end up drawing a tangent here, you notice your tangent is actually completely horizontal. So your gradient would actually be zero for the tangent because horizontal lines have m equals to zero, like completely horizontal line. When you have a complete horizontal line, you have to bring zero. So tangent gradients are zero at the turning points. That means, and what is the gradient in this chapter being represented with? Dy over dx. So since n is equal to dy over dx, so dy over dx is zero at the turning points. That's what we need to know. So you have the dy over dx already from the last part. So that's 4x cubed minus 16x. You just equate it to 0. Now, how do we solve this? You see x being common, so we can take out the x common. We also have 4 common, so we can take that out as well. So that's 4x. So that's x squared left, and that's just 4 left. Now, we can do two ways of going about this. So we can separate them up. So that's 4x equals to 0, comma, x squared minus 4 equals to 0. This is going to give me x equals to 0 divided by 4, and 0 divided by anything is just 0. That's my one answer. I need to write three set of points, so that's just one x coordinate. I haven't gotten the y coordinate here. And the two other answers will be arrived using this one. So that's uh, actually x square equals to 4. Then you can square root both sides. And when you do square root both sides, you have to add a plus and minus on one side. So that's x equals to under root of 4. Square root of 4 is just 2, so that's plus minus 2. So you're getting one answer of x to be plus 2 and the other one to be negative 2. Those are your three answers for the x, but we need the y because we set coordinates. So we need both the set of coordinates, x and y both. So we'll just use the original equation for this. So the original equation that we have is x to the power 4 minus 8x squared plus 5. And one at a time, we'll plug all the x coordinates. So for x0, we're getting y equals to 0 to the power 4 minus 8, 0 to the power 2 plus 2. So that's coming out to be plus 5. And then you plug in x to the power x equals to 2. So that's y equals to 2 to the power 4 minus 8, 2 to the power square plus 5. Use the calculator for that. 2 to the power 4 minus 8, use brackets, square, and plus 5. We're getting negative 11. So this is giving you 5, this is giving you negative 11. And last up, do not mix up the values. So do not mix up the wrong x coordinate with uh, the relevant y coordinate. Make sure you match them up quickly, correctly actually in the correct order that you have. So that's going to be negative 2, 4 times negative 2 square plus 5. Let's do that. So it's going to be negative 2. Use brackets. Otherwise, you'll get wrong answer because you have a negative value. 8 times negative 2 whole square plus 5. So that's negative 11 again. Yeah, getting the same answer as negative 11. So those are your three set of turning points. So the entire concept was equating a derivative to zero at the turning point, and I explained you the logic as well for that. Now we are supposed to determine which one of these turning points is a maximum. So out of the three, one is actually maximum nature. The other two are going to be minimum nature. We're supposed to figure out which one out of the three is actually maximum nature. So for maximum nature, uh, we're actually supposed to use now to figure out the nature either max or minimum point. Because you have the quadratic like this or like this, you have this as the minimum point and this as the maximum turning point. To figure out the nature, we use double derivative. So we'll have to differentiate the differentiated version of it, which was this. So we'll take the dy over dx, which is 4x cubed minus 16x, 4x cubed minus 16x, and now we are going to differentiate again. So we'll get actually dy square, that's the symbol we use for double derivative, d square y upon dx square, and differentiated value would be 3 into 4 is 12, so that's 12x to the power 2 because power reduces by 1, and this is x to the power 1, so 1 into 16 is negative 16, and x power reduces by 1, so that's just x, 1 minus 1 is 0, x to the power 0 is just going to be 1, so I don't need to write that, so it's just negative 16. That's my double derivative that I'm getting. Now, I need to check for the double derivative in all of the set of points I have. So I'll write this down here. Now, for the 3x coordinates that I have are these. I need to check for all three of them. And what I need to check is which one is actually giving me a negative answer. Because for maximum, you'll get negative answer. So for that, let's plug in the first one. So that's 12 into 0 square minus 16. And that's giving me negative 16. So that is the one that's giving me the negative answer. Now, since negative 16 is actually less than 0, therefore actually 0 comma 5, the entire point 0 comma 5 is our maximum point. Yeah. So we write that here. The working for this part, we'll just write this here. Yeah, so that's your reasoning for this. And just to prove it to you, the logic is consistent here. Let me just plug in another point. When I plug in 2 here, I'm actually getting a positive answer here. That's going to be what, 12, 12, 40, 12 into 4. And it's negative. That's positive 32. I'm getting a positive answer. And similarly, for I'm still getting a positive, same answer could be positive 32. Yeah. So both of these answers are actually greater than 0. So these are actually minimum points, not maximum points. We were supposed to find for the maximum point. So 0 comma 5 is going to be my maximum point because the double derivative is giving me a negative answer in that case. And that's all for this paper.